Hello, in this video, what we're going to do is find the inverse of a 3 by 3 matrix, and then we're going to use that inverse to solve a matrix equation. Okay, so when the inverse is such that when I multiply A times its inverse, it equals the identity. So when I say find A inverse, I can expand. So what I want to do is we want to solve A times, say, capital X equals the identity. And the solution for X is A inverse. Now, if it exists, the inverse doesn't always exist. And just the way, in a matrix equation doesn't always have a solution. So let me just write over here, maybe, reminding us what an inverse is. Recall A times A inverse is equal to the identity. And A inverse times A is equal to the identity. All right, so that is why I'm coming up with this little bit here, is that if I find the matrix such that A times the matrix is equal to I, that's A inverse, all right? Because A times A inverse is equal to I. And then just to further recall, I is the identity, and that's, in this case, the matrix I'm writing down here. The identity in general is a square matrix, so it's the same number of rows as column, in this case 3 by 3, and it's ones along the main diagonal and zeros elsewhere. So the thing is that in the past, a lot of times we're solving matrix equations, say AX equals B, where on the right-hand side I have a column vector. Here I have a whole matrix. But actually we can set up an augmented matrix and solve it. Now, usually we do this without any of this talk. So what I'm going to do is I'm going to set up an augmented matrix where, as usual, I write down the matrix A. But in this case, we don't just put a column vector, we put the whole matrix I there. And then what I'm going to do is I am going to use elementary row operations to find a row equivalent matrix to A that's in reduced row echelon form, which, since it's a 3 by 3 matrix, will look like the identity if A inverse exists. So I'm going to use elementary row operations and apply them to the matrix A and also on this matrix on the right, which, by the way, is the identity, and until I get on the left a reduced row echelon matrix, which will be the identity. And on the right, I will actually find my solution A inverse. So I'm starting off with what we see here is A on the left and then I on the right. So now I have to use the elementary row operations. I'll come back to why this is going to work. So I'm going to do elementary row operations to the identities on the left, and that's going to result with A inverse on the right. Okay, so first thing is that I'm going to add the first row to the first row to the second row, but first multiplying by -3. Why? Because for what I want this to be in reduced row echelon form. Okay, but maybe an easier way to say that is I want this to be the identity after I've performed elementary row operations. So I want a 1 up, starting on the first column, which is the way this should be done. I want a 1 up here and then zeros below. And so I already have a 0 right here. I want to kill this guy, this 3. I don't want that 3 here. And what I can do is I can add a multiple of the first row to the second row. Well, I want to do that to kill this 3, so I'm going to multiply this first row by -3 and add this to the second row. And so one of my things that I sometimes do is I do that multiplication by -3 and I write a little note above so that when I add it's easier. So -3 plus 3 makes 0, etc. Oh, I need to carry this over. I need to do it all the way through. Okay, so that's like just a little note there, which I never used to do at all, but then somehow I thought, oh, why don't I do that? Just sort of to make it more clear to track what steps I'm doing. So notice I'm going to copy and paste everything in my, everything's going to stay the same, except for I'm going to change the second row by taking -3 times the first row and adding it to it. So then I have these little numbers here. -3 plus 3 makes 0. -6 plus 1 is -5. And so again, how do you get the -6? I took the -3 multiplied by 2 and wrote -6. All these numbers that are in pink are the row multiplied by -3. And then possibly you're looking at it and say, no, notice I made a mistake or something, but I guess you can't say anything, but I think I got that right. Okay, so this is all done in real time here. Unless I redo the video or something. Okay, so I did achieve this 1 and then zeros below. I want it to look like the identity. So I want this guy to be, what I'm circling here, to be 1, and then everything else above here is 0. That's a little bit tricky in a way. What I'm going to do is, I don't like doing fractions. So I could divide by -5 and get 1, but I'm going to do something possibly more clever. What I don't want to do is, I don't want to add any multiples of row 1 to the other rows, because that's going to ruin my first column. It's all nicely done. But I'm going to do this. I'm going to add, back to the purple color here. I'm going to add row 3 to 2, but first multiplying by 3. So you see why I'm going to do that? So I'm going to take this third column, multiply by 3, and add to this, or third row, multiply by 3 and add to the second row. See, so what I'm going to add then is I'll have 6, -3, 0, 0, 3. And then, what the heck? Why will I do that? Well, I'm going to show you why. Let me just show you. Show me the money. Okay, I'll show you this here. So 0 plus 0 makes 0. 6 plus -5 makes 1. And then -3 plus 3 makes 0. And then 0 plus -3 makes -3. 0 plus 1 makes 1. 3 plus 0 makes 3. And so I went through all that work. And notice I copy and paste just the third column exactly the same. I did that with the idea that I wanted a 1 here, and I didn't want to divide by -5. So I thought, just this basically using times tables in my head. But if I multiply 2 times 3 and get 6, add it to -5, I get 1. There's room for creativity here, I would say. So you can do little things like that. I don't know if you call that creative, but still a little bit like that. Okay. So now like I said, I want this whole thing to be the identity. So what I'm going to do is I want zeros above that one and zeros below that one. So what I'll do is I'm going to add, I think I'll do 2 and 1. I'm going to add row 2 to row 1, first multiplying by -2. See, why would that help? Because multiplying, I'll let this out when I multiply everything by -2. Oh gosh, don't want to make a mistake. Looks okay. Okay, and then if I take these numbers and add, -2 plus 2 makes 0. And actually, I might as well just do this. -2 plus this 2 makes 0. I'll just add 2 to 3 after multiplying by -2 also. Okay, so let's see what we get then. Well, we're going to get 1, 0. See what I'm doing is -2 plus 2 makes 0. 0 plus -1 makes -1. 6 plus 1 makes 7. -2 plus 0 makes -2. I'd say there's a fair chance that I'll have to redo this video. I guess Anyway, if I redo it, no one would know. I wouldn't mention it, but let's see what happens here. Okay. And then I'll take this and add over here. I'll add those. I don't know, I'm just not super always optimistic about my, just about whether. Okay, what I'm going to do now is I have this -1, 6, -2, -5. I want this left-hand side to look like the identity. So what I want is, I don't want -1, I want +1. So all I do is I multiply row 3 by -1. So I'll just change row 3 by multiplying by -1, and everything else will stay the same. So let's get that correct. And then I want this to be 1, and I want a 0 above here, because again, I want it to look like the identity where I have 0, 0, 1. So I take, I add row 3 to 1 just by multiplying by 1. I just add them together and I get, so I just add. I'm just going to add those. So then I'll get, and that's what I get. And so what we see now is on the left-hand side, I have the identity. The left matrix is the identity. And the right matrix is A minus 1. So now the reason for that is, I can't really do a really full explanation, but we were solving this AXI, that equation. And so I wrote down an augmented matrix. And if you do elementary row operations so that you get a reduced row echelon form on the left, right? That's what I'm doing here, which is the identity, in this case, the reduced row echelon form. Then if you remember, if you were solving AX equals B, and you did this method where you have the reduced row echelon form, then the solutions would just be given by the column on the right. I don't know if it would take longer for me to really explain it. But the result is that A inverse is all this stuff here. And there was, I don't know if you noticed, there was a discontinuity in the video. That's because I made a mistake before and then I redid just that part. And so then I caught the mistake because I checked. So what needs to be done is, again, check. So let's go ahead and check that this is the solution. And so what I want to do is I want to take A times A inverse and see that in fact I get, that I get the identity. That's what I want. I want A times A minus 1 to equal the identity. So let's go ahead and just copy and paste this, duplicate it, put it down there, and then I'll do the same for this. Duplicate. I don't really want that highlight with it. And then I just multiply out and see that that's going to work. So it seems like it will, because I'm just doing it in my head. And so anyway, I guess that's sort of dull to really spend a lot of time on this, but it seems that is the correct answer. You just multiply it and then you'll see that is it. So still actually doing it. Okay, yeah, so that works. Okay, now this next part is saying, let's solve this system, AX equals this matrix using A minus 1. So where X is equal to the, like X, Y, Z, and A is from above. Now, okay, so if we multiply by A minus 1, they call it pre-multiply because you can multiply at the end or before. I'm going to multiply it before everything. So we pre-multiply, but A inverse times A is equal to I. So we get IX is equal to all this stuff. And then I is the identity. So the identity times X is equal to X. And so all we need to do then is, now that we have A inverse, X is equal to A inverse times our vector here. And I'm going to go back above and copy and paste what A inverse is. A inverse is, from part A. So I'm going to duplicate that. Well, maybe I went sort of quickly. Do you see what I'm asking you to do? I'm saying solve the equation AX equals 2, -1, 3. And all we have to do is multiply A minus 1 on both sides, A inverse on both sides. A inverse times A makes identity, so it just gives X. So we have A inverse times this right side vector. And so, and then I have to multiply that properly, which is in itself a place where mistakes can happen. Accidents, no, not, I don't know, whatever. So let's just do that. So if you remember how to multiply a matrix, I take this row and I dot the column. So dotting means 1 times 2 plus 0 times -1. Usually people just do it in their head, right? Once they get rolling on this. -1 times 3. So that is apparently 2 plus 0 minus 3. Put the final answer down here, -1. Okay, let's continue here. Different color. So I'm going to take -3 times 2 plus 1 times -1. So I'm dotting the blue and the green here. So 1 times -1 plus 3 times 3. So that gives -6 minus 1 plus 9. That's 2. I hate the idea that I'm making mistakes at the very end. I don't want to do that. Obviously, no one wants to make any mistakes. But sometimes I just, at the very end, I'm too tired or lazy. I don't know why I did make a silly mistake. Okay, let's dot this third row in the column. So that's -6 times 2 plus 2 times -1 plus 5 times 3. So that's -12 minus 2 plus 15. So, oh brother, that's just that last part. Let's see if I can pull it off. -12 minus 2 is -14 plus 15 is 1. Yeah, there we go. So this is X, Y, Z equals this. And anyway, you can, yeah. So, but actually you can double check. You can, more checking, but you can check if you want to. I don't know if we're going to do this because it's taking too long. I can take A. So if it's like on a test or something, you can take A. I want to just check everything. Multiply by X. And it should equal B, which is this matrix. So we're saying that we just found a solution, right? So this is what we're saying, find a solution to AX equals 2, -1, 3. So this is, this goes right there. So you just follow that up. I mean, this is our answer, but I'm just checking the answer. So you can check if you multiply this, 1 times -1 is -1. 2 times 2 is 4, so that's -1 plus 4 is 3. -1. So anyway, you get that, and you can go along and check it. So to make sure that works, because this is AX. This is A times X equals 2, -1, 3, and then Yeah, we want that to work, and it seems to. Okay, but that's our answer right there. All right, so that's all for the video. Thanks.